We live in an era where traveling across continents in just a few hours feels routine. But the jet engine, the powerful machine that makes this possible, is a relatively recent invention, born from the desperation of war and the ambition of visionaries. The story of the flight jet is not just about machines and metal, it's a tale of invention, global rivalry, commercial revolution, and the never-ending pursuit of speed. The concept of jet propulsion goes back further than many realize. For centuries, inventors imagined ways to harness propulsion without propellers. But it wasn't until the early 20th century that jet propulsion truly became viable. In 1930, a young British Royal Air Force officer and engineer named Frank Whittle submitted a patent for a turbojet engine. His idea was revolutionary, using a turbine to compress air, mix it with fuel, and ignite it to produce powerful thrust. Whittle's work, though initially underfunded and misunderstood, laid the foundation for a new era in aviation. Interestingly, while Whittle was refining his ideas in Britain, across the continent in Germany, another engineer, Hans von Ohain, was developing a similar design. Both men, working independently and without knowledge of the other, were on parallel paths to creating the world's first jet engine. Von Ohain's design would ultimately take flight first. In August 1939, the Heinkel He 178, powered by von Ohain's jet engine, lifted off in Germany. It was the first successful flight of a jet-powered aircraft in history. Just weeks later, World War II would begin, and the age of jet-powered warfare would accelerate. World War II acted as an incubator for jet technology. The traditional propeller planes, while fast and maneuverable, had clear speed and altitude limitations. Jets promised more speed, more range, and more power, critical advantages in a global conflict. By 1944, the Germans introduced the Messerschmitt Me 262, the world's first operational jet fighter. With speeds exceeding 500 miles per hour, it was far faster than anything the Allies had. In combat, it proved deadly. However, it came too late in the war to significantly alter the outcome. Still, the Me 262 proved that jet power was the future of aviation, both military and civilian. After the war, jet technology quickly spread across the globe. Captured German engineers and designs were studied closely by both Allied and Soviet powers. The Cold War would soon ignite a fierce arms and technology race, and jet aircraft played a central role. The United States introduced its own jet fighters, such as the F-86 Sabre, while the Soviet Union developed the MiG-15, both clashing dramatically in the skies over Korea. These early jets transformed aerial combat, introducing new tactics, higher speeds, and a deadly new level of maneuverability. But while the military applications of jet engines were advancing rapidly, there was also growing interest in using jet propulsion for commercial travel. The propeller-driven airliners of the 1940s, like the Douglas DC-3 or the Lockheed Constellation, were reliable but relatively slow and uncomfortable over long distances. Jet engines offered a new possibility: faster, smoother, high-altitude travel. In 1952, the world witnessed a breakthrough. The de Havilland Comet, developed in the United Kingdom, became the first commercial jet airliner to enter service. It was sleek, quiet, and could fly above the weather, offering passengers a revolutionary travel experience. However, early success turned to tragedy. Within a few years, multiple Comet aircraft suffered catastrophic failures mid-flight. Investigations revealed a problem never before encountered in aviation: metal fatigue caused by pressurization cycles. Engineers had to go back to the drawing board to redesign aircraft fuselages and windows to withstand these new pressures. The lessons learned from the Comet disasters led to safer, more durable jetliners. By the late 1950s, American company Boeing introduced the 707, a four-engine jet that would change the face of global air travel. It was larger, more reliable, and capable of flying transcontinental routes with ease. The jet age had officially begun. Suddenly, what once was a multi-day journey by ship or propeller plane could now be completed in hours. International travel exploded in popularity, bringing cultures, economies, and people closer together than ever before. As the commercial jet industry matured, airlines expanded their fleets with aircraft like the Douglas DC-8, the Convair 880, and eventually the iconic Boeing 747. Introduced in 1970, the 747, also known as the Jumbo Jet, was the largest passenger aircraft in the world at the time. It could carry hundreds of passengers and help democratize air travel by making long-distance flights more affordable. Airports grew larger, travel became more frequent, and the world continued to shrink. Meanwhile, engineers and nations were already dreaming about going even faster. Supersonic travel, where aircraft break the sound barrier, became the next frontier. In 1969, two supersonic airliners were introduced, the Soviet Tupolev Tu-144 and the Anglo-French Concorde. The Concorde, in particular, captured the world's imagination. It could cruise at over twice the speed of sound, Mach 2, cutting transatlantic flight times in half. A trip from New York to London could take just 3.5 hours. But the Concorde was not without its flaws. It was incredibly expensive to operate, consumed vast amounts of fuel, and was restricted from flying over land due to its sonic booms. After a fatal crash in 2000 and mounting economic challenges, Concorde was retired in 2003. The dream of supersonic passenger flight was put on pause. In the decades since, jet engines have become more efficient, quieter, and environmentally conscious. Modern aircraft like the Boeing 787 Dreamliner and the Airbus A350 use advanced composite materials and highly efficient turbofan engines, reducing both fuel consumption and emissions. Military jets too have become stealthier, faster, and more technologically advanced, with aircraft like the F-22 Raptor and the Su-57 pushing the limits of what jet technology can achieve in combat. Today, engineers are looking toward the future again, with ideas that once seemed like science fiction. Companies are developing all-electric or hybrid electric jets to reduce reliance on fossil fuels. Sustainable aviation fuel, SAF, is gaining traction as airlines look to meet net-zero carbon goals. Even supersonic flight is making a comeback, with startups like Boom Supersonic aiming to build commercially viable supersonic jets by the end of the decade. NASA and other agencies are also exploring quiet supersonic designs that can eliminate the disruptive boom entirely, potentially reopening the door to faster-than-sound travel over land. And there's more. Concepts for hydrogen-powered jets, fully autonomous aircraft, and vertical takeoff passenger jets are in development. The jet engine, once a war-born invention, is now evolving into a symbol of sustainability, speed, and innovation. As the world grows more connected and climate-conscious, the next generation of flight jets may look nothing like the ones we know today. From its experimental beginnings in the 1930s to shaping the globalized world of the 21st century, the flight jet is more than just a machine. It's a testament to human ambition, engineering, and imagination. And as we stand on the brink of the next leap forward, the journey of jet-powered flight is far from over.